We're now going to take a look at the unit system of view. Understanding the unit system can be extremely helpful uh, and really important when you're making scenes. There's an option that is only available in the standalone version. It can only be accessed while running standalone, and it controls the unit. If you go to File and Options using the standalone version, and under the Units and Coordinates tab, we'll find the length units. I highly suggest you run this outside of Cinema. So in other words, close Cinema out and open the standalone version to make changes to this length unit. Once you close View out, it will remember the length unit you have set, and when you open up Cinema and load in xStream, that internal unit will be used. It also saves out with scene files, but I've found the most compatibility definitely just opening it up first outside of Cinema and making changes to this. Changing within running the standalone open scene in standalone view is the command. I've noticed a lot of problems with that. So just to play it safe, just go ahead and run this separately. Now, by default, the internal unit is set to 0.1 meters. You can set the internal unit to, or basically our length unit, to centimeters, millimeters, kilometers, and I'm using the metric automatic mode, which is automatically going to display, once we hit kilometers, it'll display kilometers as a length unit. If we're in the millimeters, it'll show millimeters instead of having a bunch of decimal places or really, really large units. So that automatically switches that over, and that's what the automatic mode is. Meters is the main unit, and that has to do with the vector. Our internal unit right now, 0.1. So let's take a look at a cube. And if we take a look at the scale of our cube, it is showing up as 6 meters. Now, if we were to look at this as a vector, we would actually use 60. If we go ahead and control the scale of this cube, and let's go ahead and just open up the graph for the cube and add in a constant vector and type in 60 on the x, y, and z and connect our size to it, we can see it remains the same at 6 meters. So to get our vector unit, we take the display length unit and we divide it by the internal unit, which right now is 0.1. So 6 divided by 0.1, we get 60. As we change to centimeters, we now have 6 centimeters. So we would take the 6 divided by 0.1 to get 60, and then that vector 60 equals 6 centimeters. If we change the internal unit up to 1, let's just bring it back to meters, we can now see the pure vector. 60 equals 60 meters. And this can be a pretty easy way to work, but can get difficult once you get down into smaller scenes. So if we were to now change this to display kilometers with an internal unit of 1, 60 now equals 60 kilometers. The scene itself is the exact same size, although one thing that does change, and you do need to pay attention to this, if we go to the atmosphere editor, we take a look, we have an aerial perspective. Now, I think because of the way I just modified some of these settings, it did throw off the aerial perspective. So if we're changing within an existing scene, I'm going to apply the new settings to the current scene. and we should actually be seeing a higher aerial perspective. Let's go ahead and change this back. Meters, 0.1. Back to options. Let's do 0.1 or 1 kilometer. And now we can see our aerial perspective has changed. In the preview, we basically see that we're outside of the atmosphere. And our aerial perspective is set to 1, but the range of our sky and values for height have been completely changed. Our sky mean altitude is set to 7 kilometers, which was before, basically 10 kilometers was the max amount of the slider. Now 7 kilometers is right at the beginning. If we take a look at clouds, they start at an altitude of 100 kilometers and the height of 100, where before it was meters. Now the aerial perspective is the density of the atmosphere. When this value is set to 1, which you can find within the atmosphere editor under sky, fog, and haze, 1 is going to be as close to realism as you can get based on the unit you have set. So right now, using kilometers, we have a really huge scene. And looking at preview render of this, we can see the curvature being created with the atmosphere, and that's all part of the aerial perspective. And that's actually not part of the spherical scene. It can be, but this is an automatic atmospheric density. You can turn this off or lower it. Right now we have 0.1, which has reduced the overall scale. We set this to 0, click OK, and it's really not modifying it. And that's one thing about the spectral mode that you always need to keep in mind. So let's go ahead and set this to meters. And what it's done is taken the existing aerial perspective and preserved it. So that value of 1 that we had in kilometers is now a value of 1,000 when we're working with meters. Change that to 1, and we're going to get the actual density of the atmosphere. And now our sky mean altitude is important, which is kind of the fall off part of the gradient, and has to do with when that density drops off. It's not necessarily going to be the tropopause, which is normally around 10, although it does range between about 8 and 12, really depending on your location on the Earth. Closer you are to the equator, the tropopause is around, I believe, 12 to 14 kilometers, and once you start getting towards the poles, that will reduce down to 8 kilometers. And the tropopause is basically where the atmosphere and the troposphere ends. So if you've ever seen a cumulonimbus cloud up at the very top where it kind of spreads out and separates, that is the top of the cloud entering the tropopause. And there's a vast temperature change and, of course, winds, so it does spread out and it looks differently. And basically, a cumulonimbus cloud would be the only cloud that would stretch from around ground level all the way up to the end of the troposphere. So the sky mean altitude is not necessarily the end of the troposphere. It could be slightly under. Adjusting this amount will adjust the fall off of the atmospheric thickness. This can be manually changed, and it really affects the density based on height. So as we zoom out, we're going to see that density increase. So knowing your scales with the units in view will really help you understand more how these atmospherics will affect your cinema scenes, especially if you're using the spectral model, which is what all of this is part of. The only time you lose control of the aerial perspective entirely is when you're using the spherical scene method, which then the aerial perspective is set automatically. And when you're using the automatic mode within the xStream options, the units are automatically matched up. And in some of the earlier versions, it could vary, but right now it seems to be matching up really well. Although you can modify the scale if needed. And if you are happen to be wondering how I'm moving around the scene this way, since this isn't something that is typically available in the standalone, I'm actually using a meta node I created called Camera Orbiter. It's part of the product called Snowflake. If you're just wondering how I was able to move around in this way, since it is currently not possible in view. So if you're changing the internal unit, make your change. We're going to use 0.1 meters, and then you want to close out, and I'm not going to save. It doesn't matter if we save the scene out or not, those values will still be remembered. So if we were to create a new scene right now, I'm going to go ahead and take a look. We have the automatic mode set. And currently, if we take a look at my preferences, I have my units set to meters. In the previous parts of the training, I was pretty much using centimeters. If we go ahead and change that to centimeter, we may have to reset this. So it is important to note that you should stay consistent with your scale while you're working in cinema, because I just changed my unit and it didn't update view. And to prevent any problems, you really want to make sure that you're kind of starting with a fresh scene if you're going to be changing the unit, and just stick with that from there on. There are a couple of different ways to modify the scale within a view scene and within cinema as well. The best option is really to use the xStream options, because there are a lot of things you may not think about that kind of tied into the unit system. The way radiosity is calculated, any sort of global illumination, object interactions, atmospherics. It's best to make the change. If you're not going to be using the automatic mode, you want to set it to a manual. Then set it to a manual mode within the xStream options and set up the units. It is possible to scale the environment object to change the scale of the view scene. But whether or not you really want to do that, it typically causes problems. You might be able to correct some issues if you're running into problems with hair rendering or trying to get pyroclusters to work. But at the moment, I have found no advantage to scaling this. If you want to do your own testing, feel free to try different scales of the environment container and see if you can come up with anything. but it really looks like at the moment just using the xStream options is going to be the best way to go. And I just created and found a little bit of an error and a bug. And what just happened was we created duplicates of the entire scene. Try to do that again. Doesn't look like it's working. It looks like we now have two view scenes running at the same time. This is probably going to cause the program to crash. Trying to open the scene in the standalone, I guarantee will crash it. One thing I do want to see is which is the new scene or the current scene and which is the old. So if this happens, I just created a terrain. Now the positions of these objects are pretty consistent. So the terrain was created on top. We've got our main camera, terrain, sunlight, and ground. So I technically should be able to delete these bottom three, the sunlight, main camera, and ground. And that should be able to preserve the scene. And I'm just going to take a look and render and see how that's working out. And that seems to have corrected the issue. So if you run into that problem, it looks like that's a pretty good way to deal with it. Although continually working on a scene like that, it's really kind of iffy, and that's one of the reasons why it is important to sometimes separate the view file from the cinema file. Although I do want to mention that you can close xStream from any cinema file. This is done by using the close xStream command, file, and close. So anytime you have the plugin running, you can close it at any time to remove all of the view elements from the scene. You can also save the scene separately, even though you're incorporating it with the cinema file. And that way you can make outside modifications and then open or merge those scenes together. And I just want to go over one more thing before we move on, and that has to do with what is actually being set if we were to see what the automatic mode is actually using as far as units. Now the internal unit of view is 0.1 meters, and that's how we had it before. Cinema at the moment is currently set to meters. So our conversion, if we were to set this manual, is actually 1 to 1. 1 Cinema 4D unit equals 1 meter. And I did just realize that I was set in centimeters. So I did end up changing that. So if this was meters, then it would be 1 to 1. Right now it's centimeters. So actually, what we need to do, if we were to manually set this, it would be, and there's of course a lot of different ways you could type this in. But what we could do is either 100 Cinema 4D units equals 1 meter, or we could do 10 equals 0.1. And any of those should work. And then what we can do, we're going to see if this correctly worked, since things do tend to get interesting when you're changing scales frequently. We remember that cubes are 6 meters. So let's see how our scale is. This should be 200 millimeters. We'll go ahead and take a look at the coordinates and our object and the scale, and we have 200 centimeters on the X, Y, and Z. So this is 6 meters. And I also want to note that the coordinate and the scale for the view object is going to be half of the display unit. So even though it is actually a scale of 6 because it's 6 meters, it is showing up as 3. However, the coordinate position and rotation are correct. So you don't need to worry about that. So this is 1/3 of our view sphere, so we know that our units are working correctly. So that's a good comparison, is just to load in the view box, and if you know your internal unit, you should know the scale of the cube through view, and then you can compare it to the cinema object just to make sure your scales are set up correctly. Now there's one last thing I haven't really shown yet, and that has to do with infinite geometry beyond the ground plane and the C object, and cloud planes if you are using a model other than the spectral. So basically, in infinite terrain, there's one setting. If we go ahead and take a look under the view options, we have the infinite plane geometry size. This not only controls planes, as it states infinite plane, it also controls an infinite terrain. Infinite meaning it moves along with the camera, but extends to a range outside of the camera view. So when you're creating an infinite terrain, I'm going to go ahead and add in just a construction plane to be able to see the scene a little bit better and navigate easier without losing the grid. Before you add in an infinite terrain, you really want to set this scale to be your preview of an infinite procedural terrain. Right now it's at 200 meters. That might not be very high for an infinite terrain because the elevation changes by a lot. Let's go ahead and increase this to about 1 kilometer. And once again, this is something you don't want to change after you've created a terrain. If you have an infinite procedural terrain in the scene, do not change the infinite plane geometry size. I've run into multiple crashes that way with this version that I'm using. If it improves in the future and that's no longer an issue, then of course you could do it, but I wouldn't suggest it anyway, just because of the way the program works. So what we're going to do is go ahead and use a procedural terrain model. What that's going to do is load in a selection of infinite terrains that are already available. So the command, even though I have it called model, because they actually did change the name of that since I've created my interface, it's called from procedural terrain preset. So it's now a preset rather than a model. We go to load this in, and it's the same as right mouse clicking on the procedural terrain icon within the standalone version. These are infinite terrains. We have a couple of different options. You can also save out your own. A couple of questions it's going to ask. Basically, would you like to discard the ground plane? I'm going to select yes. It also wants to add a sea level object. And this is basically going to be the new ground plane. Since the sea level isn't going to be rendering, we can turn this off from the viewport. And now we can see the infinite terrain. And although our preview is only 1 kilometer, it will extend much farther. I believe it might even be 20 kilometers. This value has changed slightly. But basically, it's the extent of the scene, all the way out to the horizon. So we can zoom out a bit, and if I render this out, we're going to see all this area fill in with the terrain. So we'll just go ahead and create a quick render, and we can take a look. And I do want to note, while this is rendering out, that whenever using a procedural terrain or dynamic population with an ecosystem, there is a little bit of a delay before the render will start. What Vue is doing, which is hard to tell within Cinema, if you're running the standalone, you can see a progress bar of what it's actually doing. But what's happening is it's calculating the geometry for the procedural terrain. So it's based on where the camera's distance to the object is, figuring out the geometry, how many polygons it's going to need to generate the overall terrain, since that is a dynamic subdivision. The closer you get, the more polygons are going to be generated for that area. So that is something it needs to calculate before it starts rendering, or actually during the render, depending on the cores you're using. It will generate certain parts of the scene as it's rendering and go through, but there's always a tiny bit of delay. With the newer versions, 7.4, 7.5, it's now multi-core support, where originally that calculation was done with one core. So now all of your cores will be used for the calculation. Dynamic population works the same way. So it needs to populate your ecosystem within the camera range and also take into account any reflections of those ecosystem objects outside of the camera view. So if you have an object in the center of the scene reflecting part of an ecosystem that's not in the main part of the view, outside and being reflected, that also needs to be calculated and will show up. So just one thing to keep in mind while you're rendering, Vue will notice a little bit of a delay, and you'll also notice increased render time, as we can see right now, towards the horizon, where there's a lot more geometry, because it's going to extend very far and pretty much all the way out to the horizon. So we not only have the sky atmospheric to calculate and render out, but also all of that geometry towards the edge. So if you're looking directly down on a terrain, it's going to render much quicker than when you're lifted and pulled up with the pitch and looking out towards the horizon. So we can take a look at the render now and see that the terrain is extending all the way to the extent of the scene, pretty much wherever we need it to go. And as of the new version of Vue, as we move the camera, the terrain essentially moves with it. We're using a world coordinate system for infinite terrains, and pretty much all infinite terrains will use that system. So by moving the terrain itself, it doesn't actually move any of the details or the elements in the scene. Everything stays exactly where it is. All that happens is we add an extension, and that extension is added outside of the camera's view, really, right outside and by the horizon. So we don't need to worry about moving around and actually losing the position or placement of anything, because it is a world coordinate system to generate the fractal for an infinite terrain. If we take a look at how an infinite terrain is created, go ahead and edit our object, and now we can see we have the world mapping mode, which cannot be changed when set to the infinite mode, and then our altitude production. To change any procedural terrain to an infinite, all you need to do is go up to the upper left in the terrain editor, this button right here, and we can change it to infinite. Only a procedural terrain can be an infinite terrain. Standard terrain doesn't have nearly enough geometry, since it is based on height and basically an image defined by the pixel amount. You're also going to find that the preview size pixel resolution is no longer changeable when using an infinite terrain. So now there's a new file type with 7.5, possibly 7.4, that when you create an infinite terrain, it does save as a different type of file than a regular procedural terrain, and you can save that out in the lower right. And the quality I currently have set to high the geometry quality. Let's go ahead and set that down to low, and we can see that slightly reduces the quality of the procedural. For the most part, it's just a really small polygon amount. In order to get really high detail, you'll need to go into the standalone version to generate previews that way, because Cinema does not have enough information to generate dynamically that quality as we would move closer. So that's really as good as it's going to get for an infinite terrain. And a lot of procedurals themselves are mainly like that. So if you really need to pay close attention to the OpenGL preview, you might need to hop over to the standalone version, maybe to place a couple of reference objects, and then you can go back into Cinema. And there's just one last thing I want to mention for this lesson, and that is basically if you have a view scene open, you can only really run the plugin with one scene at a time. So if I was to create a new scene and now try to create and add in the view plugin, it's going to say only one document can contain the xStream plugin content. So what you would need to do is close xStream in order to open a new scene for a new file. So only one scene at a time running. And in most cases, even if you close out, and I'm just going to close all, I'm not going to save anything. Because I haven't closed the plugin, xStream is still running. So if you do not want it running at all, you will need to close xStream. Because right now, if I click New, we're not going to see the splash screen that says View 7 xStream and list all that information. So if the splash screen is showing up, then it was not turned on. And if it just immediately creates a new scene, the xStream plugin is running. So whether or not you want that continually running is up to you. But if you're not working on a scene with view in your cinema scenes, I would suggest using the close file close command. And that way xStream is completely closed out, and in case you run into any interference, you just really don't want to have that running in the background if you're not using it.